The last operation that we're going to be doing is adding and subtracting. So here, let's review how to add and subtract fractions. So remember, we cannot add straight and top numerators and denominators like we did before. In order for us to add and subtract, in order for us to combine these, the denominators have to be the same. So we ask ourselves, what's the least common denominator between these two? We want to make both of these 6. Because in order for us to add and subtract, they have to have the same denominators. So I ask myself, what do I have to do to this one to make it a 6? I have to multiply it by 3. But whatever I do to the bottom, I have to do to the top as well. So 15 over 6. And then over here, what do I have to do to make this one a 6? Multiply by 2. Top, top. Whatever I do to the bottom, I got to do to the top. So I get 4 6 here. So now when I combine them, you add numerators. So 15 plus 4 is 19. But denominator stays the same. So 19/6 would be this fraction. And we're going to leave everything as improper fractions. We really don't want to think about converting it to a mixed number. So that's all we have to do there. Over here, again, we need common denominators. Now it helps to make the least common denominator, but really it doesn't have to be. You're welcome to multiply opposite denominators, this one by 9 and this one by 6. It's not going to be the least one, but it's going to be a common one. You might have to reduce in the end. But thinking about this one, if I list factors of 6, we have 6, 12, or multiples of 6, 6, 12, 18, 24, so on. Multiples of 9, 9, 18, 27, so on. The least common one between them is the 18. So I want to make both denominators 18. So what do I have to do to the first fraction to make it 18? 6 times 3. Whatever I do to the bottom, I got to do to the top as well. So 5 times 3 here is 15. And to the second fraction, what do I have to do to 9 to make it 18? Multiply it by 2. So here I get 8 over 18. So once again, denominators are the same. So we can leave that part, just adding the numerators. So what do we get when we add those numerators together? 15 plus 8, 6, 23. 23 over 18. And again, just leave it. Don't worry about converting to a mixed number. And actually, subtracting works the exact same way. We still need common denominators. The common between 3 and 5 is 15. But once we make them 15, instead of adding the numerators, we're going to subtract them. So here, 3 times 5 is 15. So 5 times 4 is 20. Over here, 5 times 3 is 15. 6 times 3 is 18. And then now we just subtract top numbers. So subtract 20 minus 18 is 2. And we leave the denominator 15. So 2/15 here. No decimals, no mixed numbers, just simplified fractions. So add and subtract, and then reduce if possible. Okay, so now we're going to do this with rational expressions, which means they have an x in the numerator and the denominator. So what's the general rule? We have to, the general rule for adding or subtracting is that they have to have common denominators. If they don't, then you got to make them common denominators. Okay. If they are the same, then all you do is add numerators together. A plus b in the numerator, and the denominator stays the same. So this is just c. This one right here is actually meant to be a minus sign. If it's a minus, then you subtract numerators, a minus b, and you keep the denominator the same over c. Alright, so these first two examples, we're adding and subtracting rational expressions with, these are actually like denominators. When the denominators are the same, so notice here, both denominators are 5x squared and 5x squared. So since they're the same, that's going to be the denominator when I add them. All I need to do is combine like terms in the numerator. So here, if I combine my x's, I have a 3x plus an x, which makes 4x's. And then I combine my numbers, 2 plus -7. Right, that's -7. Oh, nope, it's a +7. Sorry, I couldn't see it. Yeah, it's a +7. So 2 plus 7 is 9. So plus 9 here. And that's really all you got to do if the denominators are the same. This is your answer here. We'll talk about reducing later if possible, but most of the time you're just going to leave it. Alright, same thing over here with subtracting. Denominators are the same. So same denominator, same denominator. So that's my answer for the first, or for the bottom part. For the numerators, now I'm subtracting these two things. So I have a 2x here. 2x minus, well, there's not an x here, so nothing. 2x minus nothing is just 2x. But then I have to do the numbers, the constants. 5 minus 7. What is 5 minus 7? We get -2. So be careful with these. When it's a subtraction sign, you have to distribute the subtraction if there's multiple things to both. Like if there was an x and a 7, you'd have to minus the x and minus the 7. So don't forget to distribute. Okay, so if the denominators are the same, fairly easy. You just combine like terms in the numerator. So here, same denominator. You combine like terms, so combine like terms in the numerator. Right, but what if they're not the same? So I'm actually going to skip 16 because we're not going to find least common multiples. We're just going to add and subtract fractions. So like right here, for example, number 17, they are not the same denominator. We have 2x and a 5x. So the 2 and the 5 are not the same number. They both have an x, so that's good, but they don't have the number the same. So then we ask ourselves, what's the least common multiple between 2 and 5? We need these both to be 10s. And since it has an x, a 10x and a 10x. So they both have x's, so we're good there. But now we got to see what we multiply by. So what do I multiply 2x by to make 10x? I multiply by 5. Multiply by 5. So here I'm going to get 15y. And I do the same thing for this one. What do I multiply 5x by to get 2y? Multiply it by 2. So I have 4y. So now that they're the same, now I can combine numerators. Denominator is going to stay 10x. And then what am I going to get when I add 5y or 15y plus 4y? 15 plus 4 is 19y. So we're still combining like terms in the numerator, but we have to make the denominators the same first. We make them the same, and then we can combine them together. Okay, so that's what we're going to be doing for these last few examples, is making them the same, and then adding the... Alright, and then here we have, again, for example, 18, denominators are different. But if you notice this denominator over here, it's a quadratic. So we get back to our x's. Come over here and set up an x. The 10 goes on the bottom and the 7 goes on the top. So what are the factors of 10 that add to 7? So 10 is 1 and 10 and 2 and 5. Positive 2 and positive 5 are the ones that add to 7. What we're going to do here This one's going to stay the same because it doesn't factor. I'm going to put an x plus 5 here, or y, I guess y plus 5. Plus y over. This one we're going to factor into y plus 2, y plus 5. So if you notice here, this one has a plus 5 and this one has a plus 5. This one has a y plus 2, but this one doesn't. So what we actually have to do is, in order to make them the same, we need to multiply this one by y plus 2. But whatever we do to the bottom, we have to do to the top. So y plus 2. So for this fraction, denominator is y plus 2, y plus 5. We need to distribute the 3 to both of them. So we're going to take 3 and distribute it to y. So we get 3y. And then distribute it to 2 and get plus 6. So that's the first fraction. Plus, this one is already plus 2 plus 5, so this one just stays y plus 2, y plus 5. So now that the denominators are the same, now I can add them together, combine like terms in the numerator. So 3y plus y makes 4y. And then the plus 6 doesn't combine with anything, so that one just stays plus 6. And the denominator stays the same. Y plus 2, you actually don't have to multiply it back out. Just leave it. Here would be that form. So when it's a quadratic, you actually have to factor it first, and then see which one is missing, and multiply it by that one. Multiply it by the one that is missing. Okay. So we're going to do a couple more. Some quadratic, some just constants. So here for 19, not a quadratic, they're almost the same, but not quite. They both have 8s, but this one has an x and this one doesn't. So to make them the same, I have to multiply this one by x. Whatever I do to the bottom, I do to the top. So for the first fraction, I'm going to get x times 5 is 5x over x times 8 is 8x minus, well, this one already has an 8x, so that one's just going to stay 3 over 8x. And then I combine my like terms. So here, denominator is going to stay the same. If I look at the numerators, I have a 5x here minus a 3 here. And I want to combine my like terms. Well, these aren't like terms. 5x is a linear and 3 is a constant. So these don't actually combine. So I just leave it as 5x minus 3. So only combine them if they're like terms. If they're not like terms, you don't combine them. So for this one, that's it. That's all we have to do. If it asks for excluded values, you can actually say what the denominator can't be like we did before, but these don't ask you that. They just ask you to add or subtract. Okay, so that's all for that one. We can't combine anything, so it just stays. Alright, now what about this one? It's not a quadratic, so we can't factor it. I'm going to go ahead and group these together so that it looks like a factor, and group these together so it looks like a factor. When they have nothing the same, you multiply by the opposite one. So here, this one doesn't have an x minus 5, so I need to multiply this one by x minus 5. So multiply whatever I do to the bottom, I got to do to the top. So now it has x minus 5 and x plus 2. This one over here has an x minus 5. It needs this denominator, which is an x plus 2. Whatever I do to the bottom, I have to do to the top. Okay, so the common denominator here is going to be x minus 5, x plus 2. X minus 5, x plus 2. So here I'm going to distribute and see what I get. So distribute the 7, and we get 7x and then to the negative 5, negative 35. Here's where you have to be careful, because we're subtracting this stuff. So my suggestion is to add and then put the negative with the 4. That way you distribute the negative with it and you don't forget about it. So if the fraction's negative, put the negative with the numerator and then you can distribute it. So negative 4x and a negative 8. So now we're just going to combine like terms by adding them together. So the denominators are going to stay the same. X minus 5, x plus 2. We combine like terms in the numerator. So combine your x's. What am I going to get when I combine 7x and a negative 4x? 7 minus 4 is 3x. And then I combine 35, negative 35, and negative 8. So negative 35 plus negative 8 is negative 43. And again, I'm not going to multiply these out. I'm not going to simplify or reduce because I can't. I'm just going to leave it in that form. Okay, so multiplying by opposite denominators if they don't have anything in common. If they're completely different, you got to make them the same by multiplying by the opposite. Okay, I think that's enough for you to finish the homework. So you can watch those, rewatch those, and then you can complete the last homework assignment. Alright, so these last few examples are more of the same thing. So just finishing off these. We need to look at the first fraction here. And factor the bottom part. So if we look here, it's not a quadratic, so I can't use the x, but I can see what both of them can divide by. They can both divide by 2, so I need to factor out a 2 from both. So divide it by 2, divided by 2. 2x divided by 2 is just x. Negative 2 divided by 2 is negative 1. So you always want to factor out GCFs if possible. And then over here we have minus. We're going to leave this one as negative 2x minus 1. But the denominator here, we're going to need an x for that one. So plus 3 and a minus 4. So what are the factors of positive 3 that add to negative 4? Negative 1 and negative 3 give me a positive when I multiply, but add and give me a negative. So that part is going to be x minus 1 and x minus 3. So if you look at the denominators here, notice they both have a minus 1. So I don't need to worry about the minus 1. However, this one has a 2 that this one doesn't have. So over here I'm going to have to multiply this one by 2. But whatever I do to the bottom, I have to do to the top as well. So we're going to multiply it by 2, and I'm actually, again, the minus sign, I'm going to change to positive and make this a negative 2. When you're subtracting, it's the same thing as adding a negative. So then looking over here, it has a minus 1, but it doesn't have a minus 3. So I need to multiply this one by x minus 3, and multiply this one by x minus 3. So the common denominator between both of them is going to be 2x minus 3, x minus 1. And then I'm adding now 2x minus 3, x minus 1. So now I need to distribute. So let's distribute this one over here first. Negative 2 and negative 2x makes a positive 4x. Negative 2 and negative 1 makes a positive 2. But for this one, in order for us to multiply this one, we have to FOIL it out, which is the same thing as using the box. So whichever one you want to do. So I don't know if I have enough room to do the box. I guess I can do it over here. I'm going to do x minus 3 and x plus 2. So that's multiplying these out. So x and x is x squared. X and negative 3 is negative 3x. X and 2 is 2x. And negative 3 and 2 is negative 6. So when I combine my like terms, x squared stays. I combine these two together. Negative 3 plus 2 is negative 1x. And then the minus 6 stays here, minus 6. So then I add them together. So the denominators are now the same. So 2x minus 3x minus 1. And I add like terms in the numerator. So if I look at the x squareds, there's no other x squareds, so that stays x squared. And then I look at the x's. So negative x plus 4. Negative x plus 4 is positive 3x. And then you look at the constants. Negative 6 plus 2 is negative 4. And technically from here you should check to see if it can factor further. So if I do another x here, negative 4 plus 3. So what are the factors of negative 4 that add to 3? We have a 1 and a 4. So we had bigger one positive and this one's negative. So this part actually, if I can fit it, factors into x minus 1, x plus 4. So now I can actually reduce. So since they both have x minus 1, I cancel them out. And my final answer is x plus 4 over 2x minus 3. Now that one was a really long one. It actually had a lot of stuff in it. I don't think we're going to see anything that big, but in case we do, there's an example. So you had to factor, and then distribute and multiply, which is the box part, and then combine your like terms. And once we combine our like terms, we were able to factor again and reduce it to this final one. Okay. The ones we're going to see are more like this next example and the ones we did before. So if you look at example 22 here. So this is more like what we're going to see. So over here we have x plus 8. And then for this one, we're going to have to factor this one with an x. So 24. Actually, this should be a y. They're all y's. And then 11 goes up here. So factors of 24 that add to 11. So 24 is 1 and 24, 2 and 12, 3 and 8, 4 and 6. And which ones add to 11? 3 and 8. So positive 3 and positive 8. So for this part, we're actually going to write this one as x plus 3, x plus 8. And it stays over 3y minus 6 over y plus 8. So now you ask yourself, what does this one have that this one doesn't? Oh, sorry, those should be y's. Y. Well, it has the x plus 8, or y plus 8, it's missing the y plus 3. So over here, you need to multiply by y plus 3. Y plus 3. That way they have the same denominator. So y plus 3, y plus 8 here. And then for the numerator, go ahead and distribute the 6. 6y plus 3. Or sorry, plus 18. And then this one already has the same denominators. Y plus 3, y plus 8. I don't have to do anything there, but I am going to change the minus sign to a plus sign by making the 3 negative. So when it's subtraction, you just make the numerator a minus, or the opposite. Alright, so now we combine our like terms. The denominator stays the same, y plus 3, y plus 8, 8, And then we combine our like terms. So 6y and negative 3y makes negative 3y. Or sorry, positive 3y. Because you're subtracting 6 minus 3 is just 3. And then the 18 doesn't combine with anything, so that one just stays plus 18. Alright, so that's all we have to do for that. That one's a little easier than the previous one, because we just had to multiply one of them. When you have to factor and multiply both, that's when it gets complicated. Alright, last example.